Oh my God, I think my LED has come loose. Just keeps falling to the bottom all the time. No matter which way I rotate it, the one that's turned on seems to move and fall to the bottom. All seriously, pretty cool trick. Some interesting maths to work out which way the LED should fall. Right? But how do we do it? Okay, now let's pretend I have a unit circle here. This unit circle has a gyro that tells us how much it rotates along the x-axis and how much it rotates along the y-axis. Now we know if we just rotate it on the x and none on the y, the LED will roll straight down the y. But if we rotate it some on the x and some on the y, it's going to roll somewhere in between the two. We need to work out how to work out what that angle is going to be. In order to know what that angle is, we need to know how much fall it has in each direction. So if we look at along here and we rotate it, we need to work out what this distance is up the side. So looking here, if it's flat and we rotate it from being flat to being up, how much does it fall down here? Now we know from trigonometry that the sine of this angle will be equal to the opposite over the hypotenuse. So the sine of the angle in the x direction will be equal to the fall in the x direction over 1, which of course is just the fall in the x direction. So we know the fall in the x direction is just going to be the sine of the angle in the x direction. And we're going to get exactly the same thing for the y direction. So if we want to know our final resultant acceleration, we can just add up how much it accelerates in the x plus how much it accelerates in the y. Now we know how much it's going to accelerate in each direction because it will be the same as the fall. The more the fall, the more the acceleration. Right? So we know the fall in the x, we know the fall in the y, we can add the two together, and we just need to work out what a is to give us the angle at which it's going to fall. Now trigonometry again will tell us that tan of a is equal to the opposite over the adjacent. So the tan of a will be equal to the fall of y over the fall of x. This is what I've written down here. But we want to work out what a is. So to find a, we need to take the inverse tan. So angle A will be equal to the inverse tan of the fall in the y direction divided by the fall in the x direction. Okay, let's look at some code. It all runs in a forever loop because I want to do it over and over and over. The first thing I do is I set my variable x fall to the sine of the gyro reading in the x direction and the y fall to the sine of the gyro reading in the y direction. Now, because I want to set my angle to be equal to the inverse tan of the y fall divided by the x fall. If x fall is 0, then I'll get an error due to trying to divide by 0. So I test to see if it equals 0. If it doesn't equal 0, if it equals 0, I do nothing. Else, I set my angle to be equal to the inverse tan of the y fall over the x fall. Okay, let's look at this bottom bit a little bit. Now, the gyro doesn't give me a reading of 0 to 259.999 recurring. It gives me a reading from between negative 180 to positive 179.999. Now, in my LEDs, I don't have LEDs numbered from negative 180 to positive 179. So what I need to do is I need to scale it down to 12 and then translate it that it ends up with a number between 1 and 12. So what happens if I get my angle and I divide it by 30, that will give me a scale from between negative 3 and positive 2.999 recurring. If I add 3 onto that, that will give me a scale between 0 and 2.9999 recurring. Now, I don't have a 0 numbered LED. The LEDs start from 1. So what I need to do if the number's between 0 and 1, I need to round it up to 1. If the number is between 1 and 2, I need to round it up to 2. And I do this with a function called ceiling. That's what it means, it rounds up. So I get my angle, divide it by 30 to scale it, and then I add 3 on it to shift it into positive numbers, and then I round it up. And I'll set that, whatever LED number is, I'll set that to red, and I'll leave it on just for a second. Because we're going to go around again and read it and update it. Now you can see is sum of +3 and sum of +9. That's got to do with the fact that when we work out the inverse tan of the y over the x, if the x is positive, by whatever the y does plus or minus, it will steer it in the right direction. But when we're doing dividing a negative by that, it flips it all on its head. So what I've said is if the x gyro is forward, we're going to put it on the first half. If the x gyro is negative, we're going to put it on the second half. All right?